starting with oxides, non-metallic oxides is acidic, metallic oxides is basic in nature. Acidic oxides, for example, hold carbon dioxide, which is a non-metal oxide, and base, for example, hold metal oxide, which is your basic in nature. So zinc oxide is there, D block. Zinc is belonging to D block, so it is amphoteric. That means it can react with acid as well as base. So let us see the examples. So some examples of zinc oxides which react as a acid is zinc oxide যেতিয়া তোমাৰ বেসৰ লগত react কৰে, it creates, see, now zinc oxide is behaving like an acid and it is reacting with the base NaOH. Okay, fine. So it is creating your Na2 ZnO2. By the way, ZnO2 2 minus. This is known as zincate. Zincate বুলি কয়. So এই কিন্তু কম্পাউন্ডৰ নাম হ'ল sodium zincate, correct? Sodium zincate plus water. So it is zincate and sodium zincate plus water. Okay. So this is where your zinc oxide is behaving like a acid. It will acid on itna behave koreche. And your sodium hydroxide is, as usual, it's a base. Okay. Acid plus base gives you sodium zincate plus water. This is one of the examples. Next example. Zinc oxide plus HCl gives you ZnCl2. This is your normal understanding. Here zinc oxide behaves as a base and it is reacting with acid. So it gives you zinc chloride plus water. Normal. So ইয়াতে তোমাৰ zinc oxide acid নিচিনা behave কৰিছে, ইয়াতে zinc oxide base নিচিনা behave কৰি আছে. ঠিক আছে? By the way, why I took this example? Because last class we discussed about something known as the oxocation. Oxocation. I mean, discuss korisilo oxocation. Definitely. We were talking about compounds of D block which formed your bond with oxygen and it had a charge, positive charge. It has a positive charge, correct? Okay. One second. Fine. So this is your zincate. So zincate here, it is having a bond with oxygen and overall it has a charge, negative charge. That is why it is known as zincate ion. Zincate ion. Fine. Sodium zincate. Overall, is the name sodium zincate. Okay. But somehow this zinc is not a transition element. তোমালোকে আগৰ পৰা জানা যে zinc transition element নহয়. Okay. Some of the examples of transition metal oxide can be copper oxide, okay, cupric oxide, all those things. So there's a special note. Transition metals forms oxide at high temperature. ठीक है. Transition metals forms oxides at high temperature. So this transition metal, when it reacts with oxygen at high temperature, it forms metal oxides. It forms metal oxides. ठीक है. Done. Okay. So mostly all the oxides of transition elements, some important points you'll write. Okay. Some important points. Okay. Mostly all the elements of like transition elements, transition metals, when they form bond with oxygen, they form metallic oxides. That's good enough, but it is mostly ionic in nature. It to ionic normally, except all oxides of transition metal is ionic in nature. Except whom? Except scandium oxide, Fe2O3. Okay, except scandium oxide. Okay. Why it is not ionic? This is more covalent in nature. Okman covalent. This is more covalent in nature. More covalent in nature. Covalent हुआ कारण तो की. What is the reason behind being so much covalent? More covalent in nature. What is the reason behind that? Okay. So first reason is already तुम लोग जाना Fajans rule पोहिसा गुट्टे के साथ. Scandium is small size cation. Okay, smaller size of cation. Scandium or size to follow. Smaller size of cation. ठीक है. Number 2, high charge on cation. High charge on cation. तुम्हें suppose हुआ scandium और oxidation number किमान होला है? If you try to find out oxidation number of scandium, it comes to be plus of 3. ठीक है. Scandium or oxidation number plus 3. Scandium or size 2 हो. High charge on of cation. ठीक है. Done. All right. Okay. Jikono metal when forms oxide, this is a very important point. This is number 1. It is number 1 boli ko para. Okay, and this is number 2. Metal when forms oxide, it exhibits its highest oxidation state. Its highest oxidation state in the group. Fine. For example, Mn2O7. So manganese nisna element or highest oxidation number ki hobo. It will have an oxidation number of plus of 7. So Mn will have an oxidation number of plus of 7. Okay, it has oxidation number of plus of 7. So since it has oxidation number of plus of 7, since the highest oxidation state is stabilized only by oxygen. Fine. Since the highest oxidation state is stabilized only by oxygen. Fine. So this is the example why, like why it is so that oxygen can give the highest oxidation state in a particular group. Okay. Oxygen বা fluorine এই দুটা হব লাগে, but fluorine আর oxygen মাজত oxygen a double bond form কৰিব পাৰে, তাৰ কাৰণে it shows a higher oxidation state. Fine. Done. So this is all about our oxides, oxoanions especially, because याते MnO2 minus, okay, Mn2O7 okay. So this is one compound. Then there are many other compounds, like you have all heard about potassium permanganate, right? One of the titration ko is potassium permanganate. Potassium permanganate. So potassium permanganate formula is KMnO4 minus. KMnO4 minus, right? K plus MnO4 minus. So MnO4 to ultimately eto naam to manganate ion, permanganate, right? This is permanganate ion. So if you see the structure, okay, this is manganese, which is a transition element, along with oxygen atoms. Okay. So this is our manganate ion. This is our permanganate ion. And in this permanganate ion, what happens? This is, you see that this is transition metal, and along with it, there is oxygen, and it is showing a negative charge overall. So, likhibo bole, to Na ka sakibo. So, this is an example of, what? This is an example of metal oxide or oxoanion. Okay? So, this is an example of oxoanion. Fine. Okay. So more examples we can see. What is the possible oxidation number? Fe2O3. Let us see the oxidation number of iron. Here, 2 times of X plus 3 times of minus 2 is equal to 0. So X is equal to plus of 3. X is equal to plus of 3. So in case of group 6, this iron belongs to group 6. Oxidation state of plus 3 is also shown by oxygen. So some of the examples. Okay. Mn2O7, by the way, one example. Mn2O7 is also known as green oil. Okay. Mn2O7 is also known as green oil. Fine. Okay. One more example. V2O5, vanadium pentoxide, right? We have seen this in contact process. Vanadium pentaoxide. We have seen this compound in catalyst. You have used it as a catalyst. Was used as catalyst in the preparation of sulfuric acid, H2SO4. In which process? In contact process. P block or right? in contact process. As a result, what happens? V2O5 is also having covalent nature little bit, but it is mostly amphoteric oxide. This is mostly amphoteric oxide. ठीक है? V2O5 is mostly amphoteric in nature. So আমি কি কৰি আছো বৰ্তমান? আমি অক্সাইড বিলাক চাই আছো, কিছুমান অক্সাইড, কিছুমান অক্সোএনাইন এইবিলাক চাই আছো যেবিলাক কমনলি ইউজ হয় ডি ব্লকত. Okay, so in case of V2O5, this is a oxide definitely, and since it is amphoteric in nature, it reacts both with acid as well as base. With acid, it becomes VO4 plus and Cl minus. This is the salt. Okay, VO4 plus is oxocation. This is a oxocation because oxygen logot bonding korise and overall positive charge is there. Okay, so next is V2O5 plus sodium hydroxide. Now it will behave with sodium hydroxide. It will form Na3VO4. See, VO4 plus H2O. ইয়াতে কিন্তু কি হৈ আছে, একবাৰ VO4 plus charge আছে, এবাৰ VO4 3 minus charge. So this is a anion, this is a cation. This is a cation, oxocation, but this is a oxoanion. Fine. Oxoanion or oxocation or difference to বুজি লবা ইয়াতে. ঠিক আছে? So what is the charge on sodium? It is +3, +1. And what is the charge on VO4? It is -3. Same compound having different charges. Okay. So some of the simple examples how we can determine some of the oxoanions as well as oxocations. One more oxides of transition elements are. This is one of the last examples. Okay, both कोइलो और ना लगे सच्चे वैसे, but this is one of the last. This is Cr2O3. Okay, chromic oxide. So this is also amphoteric in nature. Amphoteric in nature. Why it is amphoteric? So mostly at a reason দিব পাৰি that metal oxides গোটেইখিনি basic থাকে, but when the oxidation number is pretty high, it turns little bit amphoteric in nature. Okay, metal oxides are basic in nature, but when the oxidation number is high, it is mostly amphoteric in nature. It is mostly amphoteric in nature. Fine. Okay, done. So I'll just give you a few examples. V2O3. This is basic in nature. Basic in nature. ठीक है? So the question है, which of them is the most basic? A, B, V2O4, C, V2O5. There are 3 vanadium oxides: vanadium trioxide, vanadium tetraoxide, vanadium pentaoxide. Fine. Now, which of them is the most basic? Okay, is the most basic. For that, you need to select its oxidation number. Vanadium or the oxidation number to kiman pi +3. You find it out, it will be there. 2x plus 3 times the -2 kora +3 aibo. Yate vanadium or oxidation number to kiman aibo +4. Yate vanadium or oxidation number to kiman aibo +5. Okay. As the oxidation number of the metal increases, metal oxides are both are basic in nature, but when the oxidation number is high, it is mostly amphoteric in nature. As the oxidation number increases, eto to jana hai already, eto amphoteric hobo. As the oxidation number increases, it turns to be more amphoteric, less basic. ठीक है? एटो basic হয়, एटो অকমান কম basic হয়, एटो amphoteric হয়. Amphoteric means it can react both with acid and base. It has both the properties of acid as well as base. Fine. So when we compare oxides of various metals, take into consideration the oxidation number. Oxidation number jodi beshi hoy, amphoteric hoar chance to bahi jay. That much only, nothing else. Lengthenoid and actinoid, a bosor cancel kar dile hote. If you see the syllabus, it is cancelled, but I'll just do little bit so that everybody is benefited. Okay, fine. F block. Beshi nahi ha, F block. So F block, the general configuration of a F block element is NS2, N-1 D1, N-2, F1 of 14 of it. Fine. So the entire series, this entire series is in group 3. This entire series is in group 3. Okay? Group 3 আমি দেখেছি already. Group 3 কি কি আছে? And I got group 3 is there, then group 4 is there. Group 3 কি কি element থাকে? Scandium, yttrium, lanthanum, actinium, correct? And group 4 কি কি থাকে? It is titanium, zirconium, hafnium, and rutherfordium. ঠিক আছে? এটা বস্তু মন কৰিবা. This is okay. So this is 57, and this is directly 72. Okay, 57, and this is directly 72. This is the 3D series. 3D series মানে fourth period. It হলো আমার fourth period. It 4D series. 4D series. It আমার কি হবো fifth period. It আমার হবো 5D series. 5D series হলে এটা কি হবো 6th period. It হবো আমার 7D series. Oh sorry, 6D series. 6D series. It হবো আমার 7th period. ঠিক আছে? So group 3 elements কেটা কি কি আছে? Scandium, yttrium, lanthanum, and actinium. Lanthanum or element to sale তুমি গম পাবা that the difference in atomic number is 57 to 72. Major 14th element নাইকিয়া হয়ে আছে. Similarly, when you see actinium, atomic number 89, and rutherfordium 104. So you will see that when you have these two atoms, major elements get missing. Okay, 58 to 71. 58 is cerium, Ce, ferric ammonium nitrate. Cerium. It's in the F block. Cerium to lutetium. Okay, Lu. Similarly, in 88, 89, 90 to 103. 90 is thorium, and 103 is lawrencium. Okay, LR, lawrencium. So these elements are known as the lanthanoid series because they are the 14 elements after lanthanum. Lanthanum or pisor 14th element. Thorium to lawrencium is also 14 elements, and it is coming after actinium, so it is known as actinoid series. Fine. Lanthanoid series and actinoid series. ठीक है? Fine. So lanthanoid series and actinoid series. So these are the two different types of series. Just in small details, we'll do this so that we don't spend much time in all this. Okay, lanthanoids और actinoids or major difference to see. केटा मानने हैं point. ठीक है? Both are from 57. This is from 58 to 71. This is from 90 to 103. ठीक है? So this is the first point, this is the first point, second point. Only one stable oxidation state exists. Only one stable oxidation state exists because they are in group 3 only, so they possess only +3 oxidation state. This is the stable oxidation state. But in case of actinoids, which comes from 90 to 103, there is multiple oxidation states. Okay, wide range of oxidation states. Okay, wide range of oxidation states. Okay. Number 3, small nuclear charge difference among different atoms. The nuclear charge, small nuclear charge difference exists. Small nuclear charge difference exists. ठीक है? And यहाँ पे क्या होगा? It has unstable nucleus. Unstable nucleus for granted, they are radioactive in nature. Unstable nucleus, and therefore it is radioactive in nature. Fine. So these are some of the differences between the lanthanoid and the actinoids. Okay. All right. Some important points. There are some important points that we should see, and that's all. In lanthanoid, there is a very poor shielding effect of f orbitals. In lanthanoid, the shielding effect of f orbitals is very low. Therefore, the size of the atom is smaller than expected. Okay. ठीक है. और cerium to lutetium, माने cerium, this is atomic number is 58. Its atomic size is cerium or atomic size 183 picometer. ठीक है. And lutetium, the last element of lanthanoid series, lutetium, that is 71. Its size is 173 picometer. So 14 elements but you see the size does not even differ by 14 units. The size only differs by 10 units. So they are not very like the sizes between the atoms are nearly the same. And because of what reason? Because of lanthanoid contraction. Okay, already lanthanoid contraction ki hoy ami pohiso aku ebar koi diu. Lanthanoid attraction contraction takes place due to the poor shielding of f orbitals. Okay, so suppose there is a nucleus, there is the f orbital, and then there is the s orbital. Okay, so there are electrons in the f orbitals. So 14 elements electrons thakibo. So next ki thakibo, in s orbitals there are suppose 2 electrons. Now these 2 electrons will go closer to the nucleus because this f electrons these are not effective enough to push them outside, to shield them. Shield koribo noare. Tar karone ki hol, these electrons are not able to hold them outside. Therefore, the last shell electron comes closer to the nucleus. Okay? And therefore, the size becomes really small. So that is known as lanthanoid contraction as a whole. Okay? একটু ল্যান্থেনয়েড কন্ট্রাকশন বলি কোয়া হয়। ফাইন, ওকে। So like lengthenoid contraction, there is actinoid contraction also, but actinoid contraction is not that important right now. So there's something very small statement that we need to write. There is steady decrease in atomic size. There is steady decrease in atomic size of lanthanoid elements, of lanthanoid elements. Okay, there is a steady decrease in the atomic size of lanthanoid elements. Fine. Okay. Just few more points, it will be over after that. Causes of lanthanoid contraction. Causes of lanthanoid contraction. Number one is nuclear charge from left to right, it gradually increases, right? So nuclear charge gradually increases by 1 unit from therium to lutetium. Okay. Next, number 2. New electrons is added to the same shell, that is 4f. Okay. Number 3, 4f electrons are shelling to Iman weak cure. This is a very important point. Okay. 4f electrons are diffused in space. And therefore one 4f electrons, and therefore one 4f electrons do not shield another 4f electrons. Okay. Very important. So these 3 are the main reasons. Fine. Just 1 second. Huh? Okay. So these are the reasons. The last topic of CBSE, huh? This is for CBSE. The last topic of class 12 CBSE for DNF block is consequences of lanthanoid contraction. Okay. So these are the causes of lanthanoid contraction. And now we shall write few points about the consequences of lanthanoid contraction, and that will be the end of it. Consequences of lanthanoid contraction. Consequences of the lanthanoid contraction. Okay. So what are the consequences? Number one, resemblance of the second and third transition series. बुझी बेटा? Second and third transition series. How come? So we have seen that, for example, what were the elements? Scandium, that is to group number 3. Scandium, that is yttrium, lanthanum, actinum. Yate F block aha nahi okay. They do not have F orbitals. Group 4, the elements are titanium, zirconium, hafnium, and rutherfordium. Okay. This element, ki hoy? Yttrium or lanthanum is quite big in size, but zirconium and hafnium are of similar size. Okay. So this is the scandium titanium or group 3D series, is also known as the first transition series. Yttrium zirconium इनलग है second transition series. Lanthanum और इनलग जो third D block or series तो থাকে, ये third transition series है. Because it size to similar है. क्यों? Hafnium has why? What is the reason behind that? Why zirconium and hafnium has the same size? Because hafnium has lanthanoid contraction. Lanthanoid contraction is there because it comes after the lanthanoid series. So therefore it suffers lanthanoid contraction, and therefore the size of zirconium is 160 picometer, and the size of hafnium is also around 159 or 160 picometer. Okay. So hafnium or lanthanoid contraction is there, but yttrium or lanthanum or mazut bhalai difference আছে. So therefore, second transition series or third transition series or size or mazut difference to na thake because of the presence of lanthanoid contraction. These are the consequences. Mane thakile ki hoy, na thakile ki hoy. Fine. So what we have written is resemblance of the second and third transition series. Okay. Next, number 2. Number 2, similarity among the lanthanoids. Similarity among the lanthanoids. So what are the similarities? Atomic radii are almost similar. Due to which chemical properties are similar. Okay? Atomic radii are almost similar due to which chemical properties are similar, because chemical properties mostly depend on what? They depend upon the size of the atom. We have already seen how electronegativity, ionization energy, all these things dependent on the size of the atom, correct? Similarly, we can see that chemical properties are similar. Why? Because of the radii. Atomic radii are almost similar. Radii similar, chemical properties similar. Simple. Okay? So, तार कारणे actually our group wise similarity থাকে, but याते period wise similarity आहे. Period wise similarity to क्यों आहे? Because they are having almost the same atomic sizes. ठीक है? Next, so there is hydroxide number 3. Bases as base, basicity difference to की है, basicity difference. ठीक है, as a base lanthanum hydroxide to सब बोले LaOH3 হয় and lutetium hydroxide सब बोले की হয় LuOH3. So lanthanum hydroxide is more ionic. This is more ionic in nature, more ionic. ठीक है, and lutetium is more covalent in nature. Why the nature of ionic and covalency is there? This is mainly because of few things. What is the main difference? The main difference why lanthanum hydroxide is more ionic and lutetium hydroxide is more covalent is due to the fact that lanthanum is bigger in size and lutetium is smaller in size. দুটারে কিন্তু চার্জ একে, দুটার চার্জ একে, but size comparison করিলে lanthanum has lesser size or greater size compared to lutetium. Okay, lutetium or size to कम, lanthanum or size to basic. This is the main reason. Fine. ठीक है, so কোনে বেছি বেসিক হব, যোনটো বেসিক আয়নিক হয় হেতু বেছি বেসিক হয় মনত ৰাখিবা. Okay, the compound, the hydroxide which is more ionic has to be more basic. ठीक है, so lanthanum hydroxide is more basic because it is more ionic, more basic due to being more ionic, more basic due to being more ionic. ठीक है, done. All right, fine. Last topic, uses of lanthanoids. That's over. DNA block will be over after that. Uses of lanthanoids. Uses of lanthanoids. Number 1. It is used as a mixture of metals. It is used as a mixture of metals. Number 2, alloys. Alloys of lanthanoid elements are known as mish metals. They are known as mish metals, MiSH metals. ठीक है? Why? Since traces of sulfur, carbon, calcium, hydrogen are also found. ठीक है? ठीक है? So lanthanoid elements বিলাকৰ কাম ক'ত পায়, where it is found? It is used for manufacture of bullets, shells, lighter flints. Okay, and number 4 is mixed oxides. Okay, mixed oxides. So what does this mixed oxides of lanthanum does? It is used in cracking of hydrocarbon. Cracking to jana already means you break the longer chains to create shorter chains of alkanes, something like that. So hydrocarbon. Normally our petroleum industry cracking হয়. Cracking মানে ডাঙৰ hydrocarbon chain বিলাক ভাঙি থৈ দিয়ে সৰু chain বনায়. Okay, so that's all. With this we have completed your DNA block. Okay, so fine, only one chapter is left, that is the surface chemistry. For surface chemistry, we'll both have the offline and online classes. Those who are willing to join the online classes can do. Tomorrow and Thursday, there will be the online class of surface chemistry, and in 2 classes it will be over. And offline classes will be held as usual from Saturday and Monday for the class 11, for the Lal Ganesh batch, and Katigaon for the Tuesday and Thursday. Okay. So within যদি surface chemistry to attend কৰা তেনেহলে surface chemistry to শেষ হৈ থাকিব on Tuesday, tomorrow, and on Thursday. So with this, DNA vlog is over. If there is any question that I can take. If there is no question, then we can end the class. Okay, thank you very much.